Thank you very much, Darren. So as we get ready to embrace this technology and the connection to our research networks, oftentimes our municipalities are struggling to figure out how they're going to make that happen. How are we going to cross that last mile barrier that we have? Our last speaker on the panel, David Weymouth, is going to describe some of the other challenges, aside from just laying the fiber and procuring that service, that you'll encounter in making those decisions. So David, over to you, please.
Christina, thank you, and good afternoon. Just a quick word about Optelian. Optelian designs and manufactures our optical telecom systems out of Ottawa, and for the last 10 years we provided equipment, software, and services to network operators. So, next slide, please. Already got there. Thank you. What I'd like to cover are two aspects. Number one, what do our I-communities need from our communication networks? And secondly, what advances have happened in the course of, let's say, the last 10 years that would make it possible to achieve them? I'd also like to view the network in a simplified way and look for specific areas for improvements, some of the things that Darren had talked about. Next slide, please. So as we look at creating sustainable, intelligent communities, our communication networks will play a very key role. Our networks can be viewed as having three sections: the core routing, transport, and access. Core routing is basically high-speed switching, transport, haul it, and access is that portion between the customer premises and that aggregation point of the high-speed portion of the network. Next slide, please. So what is needed? The largest bandwidth needs today come from video, high-definition video in particular. Virtually all HD comes to us having been compressed. Depending on the compression and the quality, bandwidth requirements can be from 5 to 25 megabits per second. Bandwidth demands by our cell phones for voice is quite small compared to the video demands. With opportunities for teleworking, I can clearly see that multiple video sessions in a residence could require 50 megabits per second. Today, the average home will have internet access service of only 5 to 10 megabits per second. It's obviously different in Fredericton. Perhaps we should be structuring for 10 times that. There are arguments put forward for 100 megabit per second and a gigabit per second. One of the key arguments for providing really large bandwidth is that if there are enough new applications, there'll be new applications that will develop that we have not even thought of, and this will be revolutionary for the future. Businesses typically have significantly more bandwidth demands. Cloud services, where more and more applications, processing and storage are being offloaded to businesses elsewhere on the network, are being require a large bandwidth and higher service levels. Where local area networks would run at 1 gigabit per second, the cloud concepts now push for similar demands on the wide area network. Delays through the network can make it unacceptable. The quality of experience starts to be severely degraded on applications such as telepresence when delays hit to be about a quarter of a second. Assurance of quality of service needs to be measured and to be visible. Reliability, we all expect and need the same kind of reliability as per traditional telephony. The cost of service, if basic level service becomes too expensive, we won't get enough users, and the economies of scale will go with it. Access to services needs to be ubiquitous for economies of scale and for effective communities. Next slide, please. Core optical networks. The core section handles redirection of huge amounts of data. These routers support hundreds of ports, each carrying 10 gigabit per second, with 40 and 100 gigabit per second ports becoming a reality. Tremendous engineering has gone into this technology by Cisco, Alcatel-Lucent, Juniper, and others. Costs have come down in the last decade, and the reliability matches that of telecommunications-grade equipment. The packet delays traversing these routers is actually quite small, much smaller than the delay of crossing Canada with the speed of light, which is about 1/50th of a second. Where packet delays really become noticeable is if oversubscription has been applied and contention has arisen. Next slide, please. The transport. Many of Optelian's products are used in the transport network. Today's transport networks are very high speed. Speeds of up to 100 gigabit per second are becoming increasingly deployed. This is a 10 times increase from what has been the mainstay for the last decade. To put that in perspective, if each user received 100 megabits per second, guaranteed, that's at least 10 times what homes are receiving now, then 1,000 users can be served from that single channel. That's per wavelength. Fiber can carry at least 80 wavelengths, so that's 80,000 users per fiber. And the fiber is packed into cables, so a typical 244 fiber cable can carry enough for over 10 million users. These networks are agile with reconfigurable capabilities at the optical wavelength level. These networks can span thousands of kilometers with amplifier sites 50 to 100 kilometers apart. The cost of the backbone has come down over the last decade from $10 to less than $1 per gigabit per second per kilometer. Next slide, please. Access, as mentioned, the first mile or the last mile, depending on which side you're on. I really believe this is where the challenge lies. The challenge is economically getting from a concentrated delivery point out to many users. Passive optical techniques use a single fiber to splitting point and a separate fiber from there to each user premises. GPON or EPON can support a span of about 20 kilometers and provide time slots for access, delivering between 1 to 10 gigabits per second upstream, but shared with typically 32 users. One Chip, a company out of Ottawa, is making great strides in reducing this cost. WDM-PON offers more of a dedicated bandwidth, however, increasing costs at the user end. Active optical techniques use a combination of optical wavelengths, electronic multiplexers, and switches to deliver a very large and managed bandwidth. These types of deployments are optimal for business parks, high-density complexes, and campuses. Not shown in the slide are the network interface devices which provide the quality of assurance of service. Excedia Networks here in Montreal have made a name for themselves in providing this assurance equipment. The key to success in all of the above is deploying fiber. Next slide, please. Alternatives. Advances continue on copper technology, and recent reports have pushed speeds in the high tens of megabits per second over multiple copper pairs, albeit with distance limitations. Positron here in Montreal is known for their work in this area. Coax cable inherently has a very high bandwidth. However, its effectiveness really depends on how the cabling is structured. Cellular wireless is essential to our mobile world of today. It's interesting that most of the cell towers today are still fed by copper. Advances in LTE technology can offer fixed wireless access to residences, while speeds of up to 100 megabit per second are reported that will dramatically reduce with distance from the cell tower. Wi-Fi has traditionally been a home and business mechanism, but local companies such as Bel Air, now Ericsson, have made this technology part of mobile access. Next slide, please. Fiber installation. Just a little bit of info on the costs, and fiber cables come in everything from 24 fibers to over 800 fibers per cable. The cost of fiber cable has come down in the last decade. It's now about 5 cents per meter per fiber. Installation costs have remained fairly constant. Aerial at about $25 per meter. Rural buried trench about $35 per meter. Urban or brownfield applications, the cost can significantly increase. Installation techniques, however, have changed somewhat. TerraSpan out of Vancouver has introduced a unique, non-intrusive metro trenching technique. Stream Networks out of Toronto has a robotic-based system for installing through sewers. Next slide, please. Other advances. Standards organizations have played a very key role in getting common interfaces, footprints, and definitions. The Metro Ethernet Forum is one example where services and definitions have led to interoperable networking equipment. Software-defined networking is a relatively new concept where standard interface protocols will now allow for control of network elements and the flow of data through them. This will make service provisioning quicker and easier and the network more adaptive. Next slide, please. To summarize, the access needs our attention for high bandwidth and ubiquitous service. Transport and core networks are well positioned and can be upgraded. There aren't any real new revolutionary or access technologies that will be the low-cost panacea. However, there are good future-proof solutions available today to meet these access challenges. Excuse me. Next slide, please. We're at a very different technology point from a decade ago. For our I-communities, we need to focus on the access department, on the access network. Optelian is just one of many thousands of companies, Canadian companies, that are providing solutions to our networks. Thank you.